Hello and welcome to this video. In this video, we will study about more of library functions of Python 3. So first, I would like to clear the doubt which came in my previous video. I said that if there is not a complex function defined, that is underscore underscore complex underscore underscore, then you can use underscore underscore float underscore underscore, or you can use underscore underscore index underscore underscore. So we found that it didn't work out for us. So first I will clear that doubt. So we run this program, we get 2 plus, we have to get complex of this. So you see it returns 2 plus 3j. Now if we have a float function here and we return 2 plus 3j, it will give us an error. The problem is that underscore underscore float underscore underscore should always return float values. So if we return something like 2.0, what will happen is the complex part will be 0. So if you return 2.5, it will have the value 2.5 plus 0j. Similarly, if you change this to index, now the problem will be index should return integer, which will give the error again. So it returns non-int. So you make it return int, and the complex function will not complain. So you see the complex function invokes either complex or float or index. Now if we have complex function available with this, it will invoke the complex function. If all three are present, then it will invoke complex function first. You will see that it will return 2 plus 3j. So it returns 2 plus 3j. So that's what I wanted to talk about first. Now the next function which I want to talk about is del attr. It is used to delete attributes of an object. So it is, you can equivalently write del object dot attribute. So suppose we have a class x whose two values are x is equal to 10 and y is equal to 20. So we can set an attribute xyz on class x as 100, and then we can get the attribute xyz on object x. Then we can delete the attribute also, and we can try to get the attribute here xyz, which will not work out. So let's see how it works. So see, it gave us 100. This 100 is the result of this, and then after the deletion we don't have the attribute xyz on object x. So here x does not mean the instance of x, but rather x itself is an object in Python. Class is also an object, and you can manipulate a class like an object. So that's what del attribute is about. Note that certain attributes are read-only. So let me try to help you with that, what I mean by that. So suppose I say dict a is equal to a dot a colon 1, and say we print, we use dict to print the attributes of d. I'll come to dict later in this video. If you see this, so it prints, sorry, this is not dict, dir function, dir. You see it has so many attributes. Now if we say that del attr d comma, and we use some name like get. Okay, if we try to delete this, let's see what happens. it should complain that it is a read-only attribute. So it says that dict is a read-only attribute, so you can't delete it. Some of the attributes can be made read-only. We'll come to know about them later on. So now we move on to dict. So dict is kind of constructor for a dictionary. You can create them in three ways. One is by key value arguments, okay, and then you can create them from a dictionary comprehension like this, or you can give an iterable. Note that each element of the table should have only two elements, that is, they should form a tuple of two elements, and then you can have the dictionary constructor work on that. So let's run this. So you see we get first dictionary, and then we have second one here, and then we have third one from here. So that's what a dict constructor does. Now we come to dir. So when you invoke dir, it prints all the available names in the current scope. So for example, before I go into the example, I would like to read something here from the documentation. Now it can take an argument. If it's a module object, the list contains the names of the module's attributes. If the object is a type or a class object, it contains the names of the attributes and recursively attributes of its bases. That is, if you have an inherited class, that will print the attributes of the class, and then further followed by the attributes of the first base class, and then second base class, and so on. Otherwise, the list contains the object's attributes name, the name of its class's attributes, and recursively the attributes of its class's base classes. So for this, I will import a module which we have written earlier, lib2. So first we pass it argument lib2, then we have a dir argument, and we will go into these classes after that. So I hope you remember our lib2 module. So you see, in our lib2 we had only x. I'll open it for you. So the whole program is commented, as you can see, and we have only class x. So you can see that x has come here as one of the attributes from module lib2, and rest are built-ins. And similarly for this one, that is lib3, we have all the built-in attributes, and now lib2, which we have imported, is one of the attributes of this one, this module. Now we can have a class dir with capital D. We have declared x is equal to 0, and we have a dir function here, which will be invoked when you call dir on this class's object. So let's run this to see what happens here. Oops. We have a triple quote somewhere in bad place. Okay. So you see, when you invoke on the object, it has only two attributes. One is this one is x. Now, when you invoke it on the class, it has many other attributes other than x and dir. So now one of the things is that it always prints in sorted manner. So you see, this guy is the way it is printed. Okay. Now we move on to diffmod function. Diffmod is simple. Okay, I think I made a mistake here. This should be here, and this should be here. So diffmod takes two numbers as arguments and returns a/b or a%b for integers, and quotient and a%b for floats, where mass.floor of a/b is q. where q is mat.floor a/b, but it may be one less than that. So we see we first find the div mod of 5 comma 2 and then minus 0.9 and 2. So you see when you divide 5 by 2, the quotient is 2, we get 2, and this is also known as integer division, and our remainder is 1. In case of 0.9 by 2, you will observe that this is floor value of that is minus 1. So and then this is 1.1. So you multiply 2 with minus 1, you get minus 2, and then you add 1.1 to that, you get minus 0.9. So it's a very simple function. We use it at times in mathematical evaluations. Now I will move on to enumerate. It returns an enumerate object. So iterable must be a sequence and iterator or some other object which supports iteration. The next method of the iterator return by enumerate returns a tuple containing a count, and the start defaults to 0 and the values obtained from iterating over iterable. So you can use it to, say for example, quickly convert a list of months to their corresponding integral values. So for example, here we have taken January, February, March, and we enumerate on this list E, and our start value we have passed as 1. So it will print tuples of Jan 1, Feb 2, and March 3. And if you take a dictionary, then the tuple formed will be from the keys, not from the values. So let's see this in action. So it prints 1 Jan, 2 Feb, 3 March, and similarly for the dictionary. So it's quite a handy function to make such pair, or when you want a numerical value for string values. Now we come on to eval and exec. So I will not go into detail of eval and exec. I'll rather redirect you to documentation that you go and read the docs. We have seen these in action when we were discussing compile library function. So eval, actually I'll just skim over this. So eval takes one statement and evaluates, and exec takes two of them, or rather multiple of them, and then it runs them. There should be no space in between those. There is one difference though. Let's see what is the difference. So I have one eval x plus 1, and here we print x plus 1. Let's see what happens if we run this. So it printed 1, okay? Sorry, it printed 2, but let's print this guy also. And we print this also. So we run this again. So you see it printed 2, 2, and none. So in this case, eval also returns the return value of what we have executed. Here it prints 2 from this print function, but exec will return none. So you see that there is a difference between return value of eval and exec. So that's one minor difference which you can make use of when you are programming with eval and exec. So with this, we come to the end of our this video on library functions. And the next video, we will move on to more library functions, and then we'll see. So I hope that you have enjoyed this video and found it useful. If so, please subscribe to the channel and like the video so that it can reach more videos. Because you know that's how YouTube algorithm works. The more the subscriber and the more the likes, it gets shown into searches and recommendations. So please help your fellow programmers by subscribing to the channel and liking the video. And thanks a lot for watching the video. Enjoy.